Okay. Well, I'd like to welcome Norm Champion, formerly VK2NZD.
ZND.
Yeah, that's close enough.
Big difference for those.
Norm delivered a lecture about 6 years ago, and I think the subject was cutting-edge radio manufacturing. And it's still up on our YouTube website. So, long time between drinks, but welcome back. And so tonight's lecture will cover development of two-way radio in Australia and will include CB devices. But intriguingly, apparently there's some behind-the-scenes information which Norm's going to divulge, and it should be very interesting. So Norm, we're looking very much forward to your talk tonight.
Thank you. Okay. All right. There'll be a certain amount of political comments in my talk. I don't mean about political parties, but about politicians as a race and different stuff like that. I hope none of it will be offensive, but I've drawn conclusions from information or facts I've come across, and you can take your own view of whether you think that's a fair comment or not. I'm dealing with communications in the 1960s and 1970s. In the 1960s, it was pretty primitive compared to what we have today. So the only communication that the general populace had was telephones. And they were dial-up telephones, there's no push buttons or anything, and they are attached by wires to the signal. And only local calls. So if you wanted to speak to someone interstate, let alone overseas, you had to phone up a central exchange and make a booking and pay extra and all this sort of stuff. And there were also two-way radio systems, which we use the generic term taxi radios because that taxi companies were the ones that used them most. And of course, in the 1960s, all valves, and so you had to have a licence to use all those, which cost money. The government was very keen on licences then. Like when TV came in, you had to have a TV licence to watch the TV. And that persisted until 1974. And I suspect that, so it was all managed by PMG, Postmaster General's Department, which was originally set up, of course, for postage. But then when radio became involved, they established the radio branch, and the radio branch looked after things. The radio branch had all sorts of regulations of what you could and cannot do. And they were pretty tough, but understandable because their responsibility was to help out people that were having, whether businesses or privates, having radio interference from any source. And so if you were somebody wanted a two-way radio system, you had to use a manufactured one that was type approved by the radio branch. You couldn't build your own. So the one exception, of course, was radio amateurs. And so, but equally, the requirement for them was pretty tough in the 1960s. You had to do a theory exam, and they also age restricted as well. You couldn't sit for the exam before you were 15, which I discovered to my horror, and I couldn't get a licence until I was 16. So I got my licence on 16th birthday. Also, the full licence, you need to have Morse code. And I thought, why blah, blah. In actual fact, it's not the radio branch's fault. The ITU, the International, whatever it is, International Telecommunications Union, had this restriction that all worldwide radio amateurs had to do Morse code. Now, so in Australia, because we're so far away from things, the radio branch said, well, we can have a limited licence restricted to 6 metres and above. VHF, of course, doesn't go very far, does it? And don't have to have Morse code. So you either had to have Morse code for a full licence or not Morse code for the limited licence, and they were the Z calls. And since I couldn't be bothered learning Morse code, I got the Z call. There were, of course, there were no mobile phones, not even any cordless phones. There were no internet or anything. So the only way you could communicate with your friends was by phone or personally visiting them. And then in the... I remember the company I was working for in the 1960s was Commonwealth Electronics. We used to make radio links for PMG. So I was working on the VHF links, so for isolated properties or whatever, they'd have a radio link from the exchange instead of a wire. In a lot of country areas, the ones on wires actually had a shared line between several properties, and so depending on which property it is, the exchange would ring 1 ring or 2 rings or 3 rings, depending on whose was the call. And of course, equally, the other people could lift up their phone and listen to that call. So naturally, people preferred the radio link, which was theirs and theirs only. I have no idea how much they were charged, but I'm sure there was a charge for it. For Commonwealth Electronics, we've got a contract to make some what are called ISB radios. Now, you know, I'm sure you all know what a spectrum analyzer is. It doesn't work. A spectrum analyzer measures amplitude and frequencies that way. So with an AM signal, you've got a carrier. You've got 2 sidebands. So the audio frequency minus the carrier and the audio frequency plus the carrier. So you've got the information there and there repeated, and you've got this, and 2/3 of the power is being wasted on the carrier, which is why they started using single sideband, because then all the transmitter's got to do is send that. So you get much more effective use of the system. An ISB system, you have both sidebands but independent and totally insulated from each other. So that way you could get 2 channels on the one radio system. So we made radio systems for places like what were at the time backwater, like Derby and Port Hedland and I forget where else. There was half a dozen different places that had a HF radio link. And because, as I'm sure you know, HF radio works by bouncing off the ionosphere to get longer distances, but it's variable between night and day. So this radio system's actually had a big turret, and you could, with several different frequencies. So if the particular frequency they're using, which is around about the 2 to 10 meg mark, if that wasn't suitable, they'd rotate the turret to a different frequency to ensure they could get through, and that's how...
But how did the homestead know to also...
No, I'm not talking about homesteads. I'm talking about to the exchanges in these towns.
Exchange to exchange.
Yes.
Okay.
Whereas on the VHF links to homesteads or whatever, you actually had a ringing generator in the receiver, so the phone would ring that way. But that meant that...
So only a single channel, one single voice channel to a place like Port Hedland.
No, two, because Port Hedland was HF. So ISB, so two separate, they're completely independent, but with one transmission. One was upper sideband, one was lower sideband, but they weren't shared. Now, that was pretty, and again, because the radio branch, in their efforts to ensure that they weren't going to be bothered by interference, because that was their problem, they had to find out and fix up interference problems. In the case of radio amateurs, you guys do it. If your neighbours complain, well, you've got to shut down until you fix it yourself. But for commercial users, the radio branch had to chase up any interference. So they made the requirements for transmitters very, very tough, extremely tough. Like spurious products out of a transmitter would have to be at least 80 dB below the radio strength, and things like that, which is a very large amount. It's something like 10,000 times. So the radio branch dictated all these things. And young people, of course, they wanted to talk to their friends, they had no way of doing it because they didn't have mobile phones, that sort of thing. And then the Yanks introduced a thing called CB radio in America in the late 1960s, early 1970s. And that provided communication for people. No licences or anything like that. And so people started bringing them into Australia. Now, the radio branch rules were, it's not illegal to have one, it's only legal to transmit with one. And of course, they spread the story, the same as with TVs. They said, oh, the radio branch travels around and looks for people without a TV licence. How do they know if they've got a TV? Oh, the aerial on the roof. That's how you tell. I know my dad put the aerial in the roof cavity so you couldn't see it. So he didn't get a licence. It was £5 in 1960. That was a lot of money for an annual TV licence. An idiotic idea. In England, they were even smarter. You know, most receivers are super heterodyne. In other words, you've got the incoming frequency, you've got a local oscillator, which then transfers that down to the IF, the intermediate frequency, which is much lower. So effectively, you've got a little transmitter in your TV set. Remember, they're valves, so there's plenty of power. And so the local oscillator would generate a signal and shove it out the aerial inadvertently. And so in England, the radio branch used to go around snooping for the local oscillators of their TV. Knock on the door, you got a TV set, no, and you haven't got a licence. Now, realistically, it's stupid. The amount of cost of running that snooping service is way out of reach of the licence fees. So although the radio branch spread rumours that, oh yes, we're going around checking for CB radios and all those sort of things, they weren't. They didn't have the staff to do that, and they couldn't care less unless there was a problem. But it was still this thing that were illegal. And Dick Smith said, CB radios, I can make money out of these. So he started importing them. So he was the primary seller of CB radios when they were illegal. The CB radios at that time had 23 channels and AM only. How did they get 23 channels? Because of course they've got to have the transmitter generation and the receiver local oscillator, which is different. So that means 46 crystals? No. They cleverly chose the frequencies that they used and mixed them together so they didn't have 46 crystals in a 23 channel CB set. and of course truckies and the motorcyclists and the general sort of younger people all bought CB radios and all racing around. There were CB clubs and all that sort of thing, but it was all technically illegal. And eventually there was so much, the radio brand said, oh look, we can't cope with this, to the government, legalise it. Oh, okay, all right, well let's talk to the industry, because of course we can manufacture these in Australia, can't we? And so they approached manufacturers and they said, well yes, you've got to make them different to overseas. So we'll make the official CB radio in Australia 18 channels. Of course nobody else had that, so, oh, it has to be made in Australia, wouldn't it? Ha ha ha. And so people kept on using 23, and then the Yanks brought in 40 channels, so people got 40 channels. So this official 18 channel thing, eventually, give up, and they said, okay, we'll have 23 channels, and then when it becomes 40, yeah, we'll have 40, yeah, go ahead. And there were two major manufacturers of these CB radios in Japan and so on. There were two systems. One was a system by Pierce Simpson, another was a Uniden. Now, with the 40 channel sets, by then the transistors and integrated circuits were good enough that you could have phase lock loop synthesizers. So instead of having crystals, they just had a synthesizer which is digitally programmable for the channels that you want. Now, I presume you understand what a synthesizer is. Essentially, I can't remember what the channel spacing was on CB radio. It was probably 10 kilohertz. So a synthesizer will have a reference crystal and divide it down to 10 kilohertz as the standard, and then it would divide down the transmit frequency or receive frequency as programmed digitally to get 10 kilohertz, and so it would have a voltage controlled oscillator to make sure that the two matched. So you just had a digital switch to program the channels on your CB radio. And the Pierce-Simpson one was very popular because the synthesizer used a IC called a PLL02, which is a 16-pin device, and the digital inputs were outside it, whereas the Uniden system, it was all locked inside the IC. So if you had a 23-channel Uniden set and you wanted to make it 40, you had to take that IC out and put in a different one. The Pierce-Simpson one, you didn't have to do that. You just put a different programming switch. And anyway, how did I get involved in all that? In the 1970s, I was working for Hawker Siddeley on a military radio project, and a guy, Mick Slater, approached them and said, I'm importing the very first TV games, ping pong. You teenagers wouldn't know about those sorts of things, but then it was a basic thing, was just plugged into your TV set, and that's exactly what you do. Ping pong, and you must have had two buttons. I can't remember to go between the two. And he said to Hawker Siddeley, "Can you manufacture these for me?" And they said, "No, we don't want to be mucking around with something like that. Go and talk to Norm." Why they pick on me, I don't know. But and so this guy said to me, "Can you assess whether it's feasible to make these in Australia?" And so I looked at it. It was all CMOS ICs and so on, and straightforward. Yeah. So it cost about $80 to manufacture them. Oh, no, I can import them for $20. No, don't forget about it. He said, but would you be interested in repairing them for me? Oh, yeah, okay, righto. How do we work out a deal? He said, fixed price, $5 per fix. It was dollars then, yeah. Yeah, okay, I'll do that. So I started fixing these TV games.
Excuse me, Norm, so just going back, sorry to step out,
Yeah.
but have you gone back to the 1960s about two-way radio and the early manufacturing?
I'm still in the I'm in the early 1970s.
Okay.
So in the 1960s, I said there was the only two-way radios were things that were like made by Westerns, and taxi radios and stuff like that. But in the 1970s is when CB radio started coming in, and so this guy said to me to fix up these TV games, which I did, and then his brother-in-law, David Whittaker, saw the chance of business with CB radios, so he started importing those. In fact, he set up a company called Hatati. I don't know where the name came from, but that was the name. And so they started bringing in CB radios. And so they said, "No, can you fix these?" Yeah, I can fix those. But they were all 23-channel stuff. They weren't before the times of digital channel selection, all that sort of stuff. And so they had lots of crystals. I remember there was one called the Beta, and it was unstable. The transmitter in it was unstable. Now, normally the output of a transistor, a transmitting transistor, is quite a low impedance. The specifications for a CB radio were 4 watts maximum AM, 12 watts PEP sideband, when sideband became available. But and so that was into 50 ohms. You think, oh yeah, but a half-wave dipole is 72 ohms. But in fact, most of the people using like the thing with a spiral thing, a shortened, I can't remember the name.
Helical.
Helical, which were not not 72 ohms. I think they were much lower. So it was near enough, and since all the test equipment used 50 ohms, the specification was 4 watts into 50 ohms. That's okay. And the output impedance of a transmitting transistor at that power level will be a few ohms. So they use a pi network. You know what a pi network is? It's inductor, capacitor. So there's the source there, and there's your aerial there. So you can impedance match with a pi network. So I figured that if I lowered the impedance as seen by the output transistor, I would load it down more, and it might stop it being unstable, and it did work. I can't remember which capacitor I added to, probably that one. But that was one early fix I had to do. And you had other things like dud crystals and and the other thing that all these products did, of course, because they're nearly always installed by the owner. So and although we know that the red lead is positive and the black lead is negative, but a lot of people didn't realise, for instance, that in those days English cars were positive ground and American and Australian cars were negative ground. So people would put the wrong connection on the battery when they're putting it in. So the manufacturers, like you've got your incoming here, they'd have a fuse and then to the radio, and they put a reverse diode there across the supply line. So if people connect it around the wrong way, the diode would short out the fuse and blow and protect the radio. Of course, the sort of people that putting these in think, oh, I'll put in a 4-inch nail instead for the fuse, and so the diode said, ah, and fortunately always went shorted. So it did protect the radio, but quite often you get the CB radios coming in, they just have a shorter diode, that's all that's wrong with them. So $5 in 5 minutes, yeah, yippee. So it was pretty good. The most popular CB radio, well, I said there were the Pierce Simpson and there were the Uniden systems. And it was sort of not unlike Ford versus Holden. Some people only swear by, oh, we've got to have the Uniden system. Others said, no, we want the Pierce Simpson. So totally irrational, the same as this obsession with Ford or Holden at the time. That's how it was. But the Pierce Simpson one was extremely popular because with this PLL thing, you could reprogram it. Because although they had, certainly when there were 23 channels, and I think there might have been with 40 channels, they didn't have them all in a row. There were 1 or 2 blanks. And since the synthesizer had like the digital input lines, there's the 0, 1, then there's the 2 and the 4 and the 8 line. So if the channel you would switch to had a 0 on the 1 line and you put a 1 on it, you'd get a different frequency. And so you could fiddle it to operate on these unapproved channels. The other snag that happened, particularly in the early days, CB radio was very unpopular with certain groups. For example, at that time, the surf lifesavers and people like that had 27 meg radios or 26 meg radios for their emergency use. Now, again, remember, a super heterodyne receiver has a local oscillator and the actual frequency. Now, from memory, I think the local oscillator is pretty well always on the low side. And it just so happened that CB frequencies would mix with the, because the IF frequency on the handheld 27 meg radios that they use was 450 say K. It wasn't very far away. So the opposite frequency to the wanted frequency is called the image frequency. So the CB radios, some of the channels were on that image frequency, so they'd interfere with Surf Life Saving and other people like that because it just forced its way through. And so that was very distressing to those people. There's a simple solution. You just change the local oscillator to the other side of the input frequency, and that solved the problem. But of course, Surf Life Saving people don't know those sorts of things. So they were one very irate groups. Another understandably irate group were radio amateurs, because it was in the 27 meg band, which I think radio amateurs had 28 to 30, and they had a little sliver around about 27. And so they said, we're being charged a licence fee and do an exam and that, to use these frequencies. Here's these buggers all getting it for nothing and not paying licence fees and this sort of thing. So understandably, radio amateurs were irate. And so again, the government was harassed about all these sort of things. Oh yeah. Okay, we'll make it a CB radio official, but we'll have a licence fee, won't we? $25 licence fee. And so when the first day, according to the newspapers, the first day that the licensing fee became official, everybody rushed out and bought a licence fee, didn't they? Ha ha ha, yeah, of course they did. So why would you? In reality, you know the radio branch isn't going to be coming. The most they can do is fine you a little bit and confiscate your radio, but they don't want to unless you're causing real problems. So nobody bothered with the licence. The same as very few people bothered with radio reception licences or TV reception licences, because it was a stupid idea. And eventually common sense people like Whitlam in 1974 said, oh, stop mucking around, we'll abolish all that sort of thing and make it free. And the same they did with CB radio. Oh, it's stupid, people don't pay for the licences. It costs us more money to collect them than we make out of it, so let's forget about it. But radio amateurs still had to pay a licence fee. Yeah, I know I didn't like that. $50 a year, but that's how it all was. Anyway, with the Pearce-Simpson radios, if people had a 23-channel set or an 18-channel set, and they wanted it converted to 40 channels, they said, here Norm, unsoldered the digital switch, which had a lot of contacts, might have had 30 or 40 pins on it, but solder sucker, you get all those, pull it out, put in the replacement 40-channel switch, which also the reason for the number of pins is there was a digital channel number display as well as the programming as a synthesizer. So it was simple to upgrade them. The Pearce-Simpson stuff was very reliable, and another thing that attracted to people to a particular model called the Super Panther was that it was very intelligently designed. So the AM operation, the output transistor for that had a rheostat in series, so you could adjust the voltage to get exactly 4.0000 watts, so you could get the maximum of what you're allowed. So people loved that because, of course, they get a couple more watts, and of course, I've got all that extra power. They, again, not being technical, they didn't comprehend that that's a less than 3 dB increase in the transmitter power. The effect at the receiving end is negligible, and pretty well undetectable, but they thought we were getting better. Now, the other thing that with single sideband, of course, if you just have a straight single sideband generator, the louder you talk, the more the amplitude. So all SSB systems have what's it's ALC, isn't it? Automatic level control to control the output power. So of course the Pearce-Simpson radio, the Super Panther has an ALC control. So crank that up, get more sideband power. So they were very popular for experimenters because of all those things you could do. One of the things that happened was that because the company was selling thousands, Hitachi was a wholesaler. They were selling thousands of these things. And the managers, of course, the manager and all the people in the business, they weren't technical. So they're saying to me, Norm, we're getting complaints that our Super Panther doesn't have the torque power of other brands. What do you mean torque power? Oh, well, if you have a group conversation going on and somebody with a non-Super Panther radio is talking And then the Super Panther one starts talking. The Super Panther one sounds quieter. That's what they call talk power. It sounded quieter. So there are lots of complaints about that. And I didn't really understand what that was. So Hatati said to me, "Hey Norm, we'll send you to Japan for a couple of weeks to the factory, and you explain all this to them, what the complaint is, because the factory couldn't understand it either." So off I went to Japan for 2 weeks. Yippee! It was very funny because while I was there, like the technical staff that I was speaking to, were young guys, very intelligent and so on, but they were not very communicative. Most of them understood English, but I discovered if I asked a personal question like, how much do you guys earn or something like that, they'd sort of look at one another, they go, and then they just look back, no answer. They wouldn't answer personal questions. But anyway, I described, and when I first got there, the first thing they did was, "Oh, okay, well, you're doing repairs, so we've got a problem with a couple of these radios in the manufacturing line. Here's one, can you have a look at it and see what's wrong with it?" And it was a fairly obscure fault, but I did find it fairly quickly, and they, right. So that established brownie points with them, that they were happy that I knew what I was talking about. And I described the fault to them. They said, "Oh, okay, we're going to have to work on this." And it wasn't until I got back home that they finally came up with a solution. Now, because sideband speech is intermittent, and its level is intermittent, if you're going to have a level control system, it's got to deal with the fact that it's only getting occasional inputs, not a continuous smooth input. It's the same as on a receiver. If you've got an AM receiver, you just rectify the signal to get your gain control for constant audio output. So it's called AVC. TV sets, oh no, it's not volume, is it? So on the AM signal of the TV video, well, we'll call it AGC, automatic gain control. But because it was a steady signal, you could just do it. Whereas with sideband thing, because it's so erratic in a receiver, you got to have a detector that can cope with that intermittent inputs. And the same on transmitters, sideband transmitters, it has to cope with intermittent inputs. So, in fact, the control system does take a finite time to recognise the level of the signal that's coming in, and that's called the attack time. Then it's got to know how long to hang on for, which is called the hold time. So what the Pearce-Simpson people found, they said the attack time on their ALC system is too fast. So it's slugging the signal too hard, and that's why the torque power is lower. Simple solution, change one resistor. So the Hatati then delivered several hundred radios to my place and said, "Okay, can you modify all these?" So I had the family all gathered around, my children undoing, power screwdriver undoing all the screws and taking the covers off, snip out the resistor, put in another one, so on. So we mass produced all these sorts of repairs and this sort of thing, so it's all great fun. But it was fascinating in Japan. There were different things like they put me in like a 10-star hotel, and the chauffeur to the factory every day, that sort of thing. After the first week, there was this, and they'd said to David, the owner of Hitachi, they said, "Oh, we'll take care of the accommodation." Okay, so Norm said, "They're giving you accommodation." Right, that's okay. At the end of the first week, there's this bill under the door for the accommodation, and being a 10-star hotel, it was pretty big. And so I went and spoke to the manager. I said, no, he actually spoke to me. I thought that they've just given me a copy of the bill, and I ignored it. And so the general manager came to me and he said, "Oh, you're most embarrassed." And Japanese people are very formal, so he's sort of standing there like that, clicking his heels and saying, "We've got this problem, you haven't paid the bill." I said, "Yeah, you said you were going to pay the bill." "Huh? No, we didn't say that. No. If we were going to pay the bill, we wouldn't have put you in a 10-star hotel. It would be one and a lot closer to the factory, so you could walk there instead of having our driver do this." Okay. So he rang David, and David said, "Okay, well, you pay the hotel bill and we'll refund you." Now, because I got this freebie, I took my wife along as well. And so when I got back, he said, "Okay, well, we'll pay your cost, but not your wife's. So you pay half." Which was actually to their advantage, because it doesn't cost twice as much in a hotel room for two people as it does for one. So I got...
You got gypped.
Well, I got disadvantaged a little. I can't remember if they paid me for the time I was there. They must have, because I'd taken time off work to go there. But
excuse me, Norm. So coming back, it sounds like you had a lot of fun and exploits over there. But coming back to Australia, was anybody manufacturing CBs, and what's all this behind the scenes stuff that you're alluding to?
There wasn't, because see, the government thought, well, we'll bring in the 18-channel sets because nobody else has them in the world, so therefore they'll have to be made in Australia. And of course Australian manufacturers will race to build them. Well, they couldn't possibly build to the cost of getting it from Asia. Just nowhere in the world. And eventually the government, I guess the polys they're lawyers. They know nothing technical, so they get conned by manufacturers and by the radio branch and all those sort of things. So they said, okay, well, to encourage local manufacture, let's have a unique system in Australia. We'll have a UHF CB system, around about 476 megs or so. And nobody else has got that, so of course they'll have to be made in Australia. This, of course, was campaigning by Philips, because Philips had taxi radios and so on. So Philips said, "Oh yeah, make this the law, and then we'll manufacture in Australia." And of course, everybody rushed out and bought UHF radios when they became in. Philips UHF radios were $450. 27 meg radios are $50. So of course, all the truckies and everyone else all rushed out and bought those, didn't they? And, And of course, in the 1970s, that was a lot of money. So, but it's also the same thing, is that the government was fooled into thinking that 18 channels would, on 27 meg, would cause local manufacture, but it didn't. They just can't compete. So because it was a closed market initially, because Australia was the only one that had UHF CB at that time, of course Asian manufacturers weren't interested. Like the factory there, they said to me, we can, if you want, we can make you a brand of radio called Norm's CB, if you want. Minimum 10,000. Because it's just not worth their while to do it for less. So it wasn't worth their while to start making UHF radios at that time. Eventually, some companies did, but also other countries started to have it as well. I think New Zealand and Canada have got UHF CB, and I think it might be available in Europe as well, not in America, I don't think. Anyway, it became practical for Asian manufacturers to start producing UHF CB sets, and so that became available. It was also interesting to me personally because in the 1960s, when I was working on radio links, the standard for a radio receiver was that it had to be able to have an acceptable reception with a 1 microvolt signal. So for AM or sideband, you'd say 1 microvolt, you should get at least 10 dB signal to noise. And the same with the VHF systems, which were FM, you had to have 1 microvolt, you get at least 20 dB quieting on the FM signal. So that was the best that transistors could do at those days. We're talking about OC71s and silicon transistors were just starting to trickle out, all those sort of things. So in the 1960s, we couldn't make UHF radio links. Early 1970s, finally, some semiconductors became available that could do those sorts of things. And so I was involved with UHF radio links as well. But it was interesting to me that when Hitachi got the first of their Asian UHF radios in, the sensitivity, now, the normal accepted sensitivity of a radio receiver was 1 microvolt. HF, it didn't matter because the background noise is so high that if you could make the receiver more sensitive than that, there's no point, because the outside noise would mask it. But of course that's not the same on VHF and UHF. And so the sort of transistor, I measured one of these receivers for, of course, UHF CB is FM, it was 0.1 microvolt sensitivity, not 1 microvolt, 0.1 microvolt. That's how much the transistors had improved in that time. Now, of course, you can get transistors that work at gigahertz, but not then. So, like you've got Foxtel or something like that up on the roof. Of course, there's an amplifier module on the aerial, which is a down converter as well. So it amplifies the microwave frequencies that Foxtel and that use, and down converts it to a lower frequency to shove it down the coax to your TV system. So, oh yeah, when I was being sent to Japan, to the factory, David called me into the office. He said, okay, well, just one thing we've got to tell you. When you go there, don't mention our pharmaceutical business. Now, when Mick Slater first approached me, he just said that his main business was vending machines. He stocked vending machines. So I thought, okay, he's going around filling up drink machines and different stuff like that, so on. And so I said, David, what do you mean by pharmaceutical? He said, oh, don't you know? I said, no. He said, oh, yeah, Mick looks after that. He said, I'll show you the catalogue. And it's all sex toys and things like that. So
No, just coming back to the market then, where did Dick Smith enter the market, and how did that affect?
he was the first in, but his were fairly pricey. Dick Smith liked to make a good profit, so his was fairly pricey. And Hitachi were wholesalers, but there were lots of CB businesses sprung up, so Dick Smith gave up because theirs were all cheaper than his. So it's just that he kicked it off because, as I'm sure you've observed, Dick Smith is intolerant of any regulations that he feels are stupid. And of course, having CB radio illegal was stupid because it's depriving people from being able to talk to one another. And licensing was stupid in his idea. So he just did it because he knew he could, and he didn't care. And again, it wasn't illegal to sell CB radios or to have one, so he could sell them. So it wasn't a problem.
But there were also others in those early 70s. There's people like Sharp had a very popular CB radio they used to sell.
I don't know, because I only saw the ones that Hitachi handled, which was essentially the Pierce Simpson range. And so they were very, very popular because you could do things with them. And of course the word got around very quickly of all these fiddles you could do, I'm not being disparaging of the sort of bikey sorts of types are more earthy, and they are not going to follow regulations and things if they don't have to, and they've also think, oh yeah, I can get more power out of my radio. Oh, won't that be great? I'll be able to get far, far further than other people. In fact, some people actually used like amateur band beams, and because a 10-metre beam, perfect. Other people used linears to boost their power as well, because you could buy 1 kilowatt linears from America, couldn't you? So there's all these sorts of different fiddles that went around, and again, the radio branch didn't have a lot of staff, and they didn't chase up anything unless they had to, because they just couldn't afford the time. And from the point of view of 27 meg was not a terribly important part of the spectrum, because it's where all the industrial diathermy machines are and all these sorts of different things. So there's lots of radio noise around. So it was an unimportant area of the spectrum. CB, some CBs loved it because on occasions when conditions were right, particularly at the high sunspot cycle, you could get skip. So I remember testing radio, I could hear somebody in Peru because it just happened to be the skip on at that time. So the skip is where you get multiple bounces or whatever, but it did happen. So they loved all that. Competition's the same as amateur radio operators for, well, actually, I got stuck with that. When I was working for Hawke's Siddeley, because we were all interested in microwave stuff and all that sort of stuff, we set a microwave distance record in Australia for 10,000 megs and 5650, which was available at that time, and 3,000 megs. We set distance records with valves, of course.
So, Norm, we've got a few minutes to go, so maybe open it up to any questions from the audience.
I've pretty well covered the sort of the general sort of thing at all.
No, where did you start to see the decline of citizen band radio, or what precipitated that in your view?
Oh, well, it started, my involvement started with Hardy. I didn't just do CB radios because they started getting other things like cordless phones and things like that. In those days, the cordless phones were relatively low frequency. There was one that had the receiver on about 1.8 megs and the transmitter on, I forget, a bit higher. And it was quite funny because David said to me, he said, sometimes people drive, because then STD had come into operation, so you could dial interstate calls, but it wasn't the cost of a local call, it was expensive. So people would drive around with the handset of this particular thing with it turned on and listen for a dial tone. When they had a dial tone, they knew they're in someone else's system and they'd make their long distance calls and things like that. And there was also, I got one which was actually like a proper telephone, and they only had 5 channels, and I picked this particular thing up to listen one time. I could hear this conversation going on. There's a woman talking to her daughter, and her daughter was whinging about her husband, what a terrible person he was, and all that sort of thing. And I listened to this conversation and thinking, I'm on the same channel. So eventually I said, if I were you, I'd drop that guy. There was a stunned silence.
Norm, what was the sort of conversion rate from CB as moving on to amateur radio?
I've no idea.
Percentage?
I wouldn't think so.
When did you get your licence? Is it?
I got mine, say, when I was a teenager.
Oh, okay, right. So you've seen the whole thing?
Yes,
The whole
yeah.
spectrum.
Yeah. Which is why, because later on, eventually they saw the common sense, the stupidity of doing 15 words a minute Morse. So they did bring in whatever they call it these days, but junior licences for 5 words a minute and novice, yeah, all that sort of difference. So they gradually started to see common sense. But no, it's.
Well, you're pleased to know that I looked up the ACMA and your whole call sign is still available.
Okay.
To ZND.
Yeah, well.
So it doesn't cost anything.
Yeah, well, now it doesn't cost anything. I dropped it after about 40 years because I got sick of paying this fee and I wasn't really using it. And of course, a few years later, they then stopped having the restriction of having Morse code. Because now the limited licence doesn't exist anymore, I presume. So I could have got an HF, but I.
Okay, well, thank you. Norm. Any other questions regarding Norm's talk? Well, really appreciate that, and make sure you come back in 6 years' time and do another one.
Oh,